Greetings, everyone. Welcome to today's webinar, which is going to cover a step-by-step plan for updating and migrating Microsoft Windows Server 2003 workloads to the AWS platform for .NET applications. Today with us, we have myself, Josh Hoffman, with Amazon Web Services. We have MJ DiBerardino, who's the CTO at Cloud Nexa, and we also have Paul Andruski, who is the Cloud Architect for Cloud Nexa, leading their AWS practice. Throughout the webinar, you'll have the opportunity to submit questions using the Q&A tool at the right of your screen. Please feel free to answer, or rather to propose any questions you have, and we'll answer those at the end of the webinar with the remaining time that we have. We'll also be posting the webinar to SlideShare as well as the live broadcast on YouTube once we're done. So today we're going to cover a really quick overview of Amazon Web Services, and we're going to talk about how to upgrade your server infrastructure and migrate those 2003 workloads to the cloud step by step. And then lastly, Cloud Nexa is going to give a demo of their VNOC product, which gives insight into the operations management and visibility of that cloud architecture. And then finally, we'll wrap up with Q&A. So before we get into migrating specific 2003 Windows Server workloads, well, that's a part of our compute portion of our platform. It's also important to highlight that AWS has a ton of different products, and they're really made up by our three pillars of compute, storage, and database services. And with our compute family, we have a number of different instance sizes for different needs and applications. We have a number of different storage products, such as our S3 and our archiving storage called Glacier. We also have a number of different database products, such as our Redshift Data Warehouse, our DynamoDB NoSQL database, as well as other RDS services for Oracle, MySQL, and SQL. On top of that, we have a number of application services and deployment administration tools that make it easy to automate, provision, and then maintain those applications once they're live. And sitting on top of all of that is our global infrastructure that consists of 9 regions around the world. Within each of those regions, we have, or in total, 25 availability zones. And that allows our customers to create very fault-tolerant, high availability applications running across multiple availability zones in a region. Also allows for easy backup and other types of disaster recovery scenarios so that you can achieve a very, very high SLA. And we continue to expand with new regions around the world as our customer demand dictates where we expand into. While we work with hundreds of thousands of customers in over 190 different countries, we also work with some of the largest organizations in the world, helping them solve specific problems, or in the case I'll highlight here with NASDAQ launching an entirely new line of business with NASDAQ called FinCloud. We're very proud for the 3rd year in a row to be at the top of Gartner's Infrastructure as a Service Magic Quadrant. And in particular this year, it was interesting that they highlighted some specific metrics around capacity. And in complete, or in totality, when you look at all of the other vendors represented, Amazon Web Services has over 14 times, or the aggregate, or I'm sorry, 5 times the aggregate capacity of all the other 14 providers combined. So we're very, very pleased with that. We're very proud of that. There's 3 ways that enterprises use AWS. The first is to augment on-premise resources with additional cloud capacity from AWS. The second scenario is where we'll migrate existing applications and data to the cloud, which is today's webinar topic on Windows 2003 Server. And the third scenario is where businesses such as NASDAQ will build entirely new lines of business or launch new applications and sites on top of AWS. So with that, I'll hand it over to Paul, who's going to get into the details of how we can help you migrate Windows 2003 workloads to AWS.
Thanks, Josh. So let's consider a typical scenario. We have a customer who either self-hosts their own environment or has their infrastructure hosted at a data center or co-location. Windows Server 2003 is nearing its end of life, and this acts like a catalyst for them to start thinking about upgrading their .NET applications. But since they're already going to be investing time into upgrading, they also want to use this exercise as an opportunity to migrate their applications into the cloud. They've chosen to go with AWS because of the immediate perceived benefits. The customer will see cost savings with no upfront investment. They know how easy it will be to provision resources. They understand the value of flexibility through dynamic capacity management. And they want value from increased efficiencies. With the AWS pay-per-use pricing model and features like auto-scaling and elastic load balancing, customers can effectively achieve close to 100% asset utilization. In terms of technical drivers for upgrading to the latest versions of IIS and .NET, customers know they'll see increased benefits in security, performance, management, and scalability. A .NET migration project can be broken down into a number of phases. This slide shows Cloud Nexus Customer Engagement Framework. This is essentially the end-to-end process that we would go through with the customer. It's a model consisting of the following 6 stages: assess, plan, design, deploy, migrate, and manage. In this particular case, we're going to use this framework to address the .NET application migration and upgrade project. In the first phase, we go through our initial requirements gathering process. This can occur on-site or via conference call, and it's typically supplemented with questionnaires and diagrams to fully understand the existing environment. We identify the customer's ultimate goals and critical success factors. We document our overall application architecture and the hardware-software footprint that it takes to support that architecture. We discuss the quantity and the type of applications that are being migrated and also determine the priority for that migration. This way we define the order the apps will be migrated in. We identify existing supporting infrastructure components, for example, how the environment is currently secured and what maintenance management tools are in use. We also look at how high availability is implemented, what technologies facilitate HA, and the degree to which the environment is fault tolerant. Finally, we look at disaster recovery for the applications and a business continuity plan if one exists. The next phase is where we plan the migration and deployment. We need to look at a few key decisions before we can propose any kind of design. For example, account structure. Is the customer going to have one account for the deployment, or do they require separate accounts for dev, QA, and prod, for example, for internal compliance reasons? Connectivity. Is this environment going to be exclusive to AWS and completely isolated in the AWS cloud? Or is there going to be connectivity back to the customer's on-prem environment over a VPN? Or perhaps direct connect will be required to bypass the internet altogether. The migration approach. What does the migration approach look like? Are we simply moving the environment as is with the intent to upgrade as a phase 2? Or are we building a new environment already upgraded to the latest version edition and then migrating the data and application code into that environment? Are we also re-engineering components of the application architecture using cloud-native constructs? For example, if we're moving Microsoft SQL Server, it's possible that we can switch to the AWS Relational Database Service version of MS SQL Server. Basically, we need to identify the degree of accepted modification or refactoring that the customer is comfortable with during the project, or identify it as an action item for the future. And also, we look at the duration of coexistence for the old and new environments and determine an acceptable time frame for cutover. During the design phase, we formally document and propose a high-level architecture in AWS for the project. The deliverables during this phase of the project typically consist of a high-level design document, a deployment roadmap with project phases and milestones, and the identification of gaps, risks, and mitigation steps. This will usually go through about 1 to 2 iterations with the customer before we have the final version. But at that point, we have an agreed-upon baseline and a definitive roadmap for the project. We fully document the existing environment and any design decisions that have been made in terms of refactoring the application. And we also identify any additional third-party software that may be needed to satisfy customer requirements that are not adequately addressed through native AWS means. So the next phase will bring us to the actual build. Our average build can be broken down into a sequence of 4 high-level stages. We build the AWS network and configure the appropriate level of connectivity with customer sites, whether VPN or direct connect based. We launch the base infrastructure resources to support the operation of our environment, and this can include Active Directory, antivirus systems, patch management, and monitoring resources. We configure the Microsoft resources that will support the migrated application infrastructure. This will include server instances, Windows operating system roles and features, additional IIS modules, and database resources. And lastly, we deploy and integrate AWS and third-party services to support or augment the migrated application infrastructure. So if we're going to take our infrastructure and turn it into an HADR build, this is typically what it would look like. We would have our primary infrastructure deployed in a specific AWS region, in this case US East. We would expand into an additional region to facilitate inter-region failover into US West. And we could use additional regions such as the EU and Singapore, AP Southeast 1, as our DR site. Tying up our regions together would be AWS Route 53 and latency-based routing. The process for migration would typically look like this. We would have an empty VPC already created with our base constructs, meaning the network infrastructure, routing, security groups, and whatnot. Then we would migrate the application using a tiered approach. First, we would move the database tier either directly onto EC2 instances in the cloud or switch it over to RDS. Following that, we would migrate application tier resources. Following that, we would move web tier resources. And lastly, we would switch the proxy tier into both internal and external load balancers, either handling customer traffic or handling application traffic in between tiers. Now, if the customer is okay with it, we typically recommend and move them from their current DNS provider to AWS Route 53. We typically recommend this because AWS Route 53 integrates very nicely with the rest of the AWS stack, so it makes it easy to launch new features or take advantage of features such as LBR. The last phase in our migration will be the cutover, at which point we cut over DNS from the source environment to our environment running in AWS. In terms of migrating .NET applications off of IIS, there are some items that you should consider. For one, IIS 7 was a complete redesign and rewrite of IIS. This rewrite included a new modular design that allows for better security and increased performance, but also a hierarchical configuration system to simplify management. The new structure of IIS can create some challenges to migration, but IIS 7 and newer versions maintain backwards compatibility with previous versions through a mechanism called Classic Mode. Classic Mode uses the IIS 6 processing pipeline for hosting ASP.NET applications, and it does allow you to run applications developed using ASP.NET version 1.1 on any IIS server without modifying the application to run in integrated mode. To assist with migration, you can also look at specific tools such as the IIS migration tool. And for anything more heavy duty, we can take a look at services like AppZero, which facilitate automated migrations for moving server apps to and across clouds or data centers. The final phase of our customer engagement framework is where we fully transition the customer to a managed services agreement. The environment has been deployed, the applications have been migrated, and we've had a formal production cutover. Now it's time to support ongoing operations. The total operating environment will typically consist of the AWS ecosystem, the underlying network, core infrastructure and supporting services, the guest operating system environment, Active Directory and Microsoft stacks such as SharePoint or Exchange, and custom .NET applications if applicable. To help us work efficiently and to handle high work volumes, our team uses the following tools for customer projects involving Microsoft workloads in .NET. The VNOC Management Suite, which you'll get a demo of very soon, the AWS Console, AWS Tools for Windows PowerShell, AWS Toolkit for Microsoft Visual Studio, and the AWS SDK for .NET. And with that, I'm going to pass it over to MJ DiBerardino, who's going to demonstrate the VNOC Management Suite and how our team uses it.
Thanks, Paul. Okay, so I'm logged into our VNOC Management Suite dashboard, and the first thing you'll see here is a high-level view of those environments that you have now migrated over to Amazon. A couple of things I just wanted to point out here on the dashboard. Up here in the top middle, VNOC does a one-to-many management ratio to your Amazon accounts. So for many of our organizations that we currently manage, we find it common that you'll have needs to open up multiple AWS accounts. Maybe you want to keep your application separated, and this is one mechanism to do that. And then in the middle here of our dashboard, you'll see the concept of resource groups. And resource groups is a way that you can break out the cost. And resource groups are defined by our clients. And again, these can be by application or by environment. So maybe you want to break out your dev environment compared to your production environment to get more of a true cost. Diving deeper into managing your environment, I'm going to show you an example of one of our server grids. When this is pulled up here, you're going to get a global view of all of your cloud accounts and environments across all of your AWS regions. So if you're deployed, as Paul was mentioning before, in more of a HA or DR use case, you'll be able to see that all within one grid. And then you'll get some key metric data, such as CPU or memory. This is what we're pulling from CloudWatch. And then additionally, you can dive in and see more of the details behind that instance. Additionally, what Cloud Nexa will help our clients do is help automate the deployment process. So once you've decided and gone through the process of what applications you want to migrate over, we want to introduce a layer of automation to that process. So we will leverage CloudFormation, which is Amazon's scripting tool. And here's just a basic example related to S3, but we can leverage this for the ELBs and EC2 as well, of how you can automate that deployment. And again, we're here to help develop that for you throughout the design and migration process. Additionally, within VNOC, you can introduce a level of automation, for example, your backup policies. So once you're on the cloud, your application is running, you want to ensure that there's a backup schedule that's being met for all of your instances. So you can create this. You can also put a retention policy to those backups, so that way you're not paying for the added storage that you may not need. And then the last part of that is being able to copy your backups to additional regions for more of that DR use case. Now, going beyond the cloud there, when you actually need to go and manage one of your instances at the OS level, we have a module called Access Manager. And Access Manager is a way for you to connect directly to your instances through a HTML5 module. So this is supported across platform. It supports iPads and even mobile devices. So now, as you see, I clicked onto an instance and I'm directly logged in to my new Windows server that I need to manage. Just for your information, all actions that are performed through VNOC, there is an audit log, so you can track your users, what they're doing, what they're touching, what they're managing. Everything is tracked through an audit log and provided back to you. And the last thing I want to highlight in this demo is a way for you to interact directly with the Amazon services. So through the Cloud Account Manager, you can select the AWS account that you want to request access to. depending on the level of permissions that you set for your users, you can have full access, read only, things of that nature, and then also limit their time that they would have access. So everything is temporary access, so that way you can have more control over what your users are doing within the AWS console. I'll now hit Get Access, and it has logged me in to the AWS console. Now, a couple things to note here. It is actually account type federated, so you do not need to manage an additional set of users within the AWS console. And then additionally, what VNOC will offer is through identity services, you can bring your own identity service. So if you are using Active Directory, you can extend out Active Directory into VNOC and be able to have more of a single sign-on approach. So you can have your Active Directory authentication into VNOC, into your instances, and then into the AWS console. So with that, I'll hand it back over to Josh, and we can continue with the Q&A.
Thanks, MJ. So before we get started with Q&A, we're going to do a quick poll. You should see a message there on the right-hand side of your screen, and we'll pause for a minute while everybody answers that, and then we'll see those responses immediately before we go into Q&A.
Good evening, everyone. Thank you, Josh. The poll is complete.
Okay, excellent. So I've got a couple questions here that people have submitted, and we'll go ahead and go through a couple of those. The first one is, which version of IIS would you recommend migrating to and why? So Paul, I'm going to throw that over to you to talk about that, and I've got a couple other related ones I will likely throw at you as well.
Sure, not a problem. So we'd recommend just moving to IIS 8 until AWS releases the AMI for Windows Server 2012 R2 with IIS 8.5. I mean, basically, IIS 7 is the complete rewrite, so this is going to form the basis for all the newer versions, whether it's 7.5, 8, or 8.5. You really can't escape the rewrite, so you might as well take advantage of all the latest features and capabilities with the newest version that you have access to.
And a related question was, what is the main difference between IIS 7 and IIS 8?
So IIS 8 offers several key enhancements over IIS 7, and I can just list a couple of examples. For one thing, IIS 8 now supports dynamic IP restrictions, which means that it supports automatically blacklisting IP addresses based on the number of requests. IIS 8 also expands SSL host header support and introduces a centralized certificate store for SSL. And there are additional features such as CPU throttling for websites, the application initialization module, which is something that allows administrators to initialize certain applications in advance, so you don't have to deal with that long timeout period on the first time that somebody hits a website. And IIS 8 also introduces WebSocket support. Okay.
There was also one question on a particular slide on the Migrate application environment slide. The question is, you had elastic load balancers in the diagram listed twice. Why was that?
So AWS has both external elastic load balancers and also internal load balancers, internal elastic load balancers. In our example, the external elastic load balancers are the public endpoints that the customers connect to using public DNS. These external ELBs will then direct traffic to a fleet of web server instances, the ones which they're proxying for. Internal load balancers, those are typically used for application traffic. So in our example, they act as endpoints for application traffic coming from the web tier, and in essence are proxying to a fleet of back-end application systems.
Okay. One other question just came through, which was, what is the pricing model, or how much does the VNOC tool or management layer cost?
This is MJ. I'll take that. So that's a good question. So basically, there's no added cost to use VNOC as part of our service. So our full offering is called Cloud Management as a Service. It is a flat 18% of your AWS spend. And additionally, if your AWS spend is under $2,000 a month, then currently we have a program called Free 2K, and there's actually no percentage on top of your AWS spend to utilize not only our full managed service offering, but VNOC platform as well.
Okay. And I've got one other question here, which is, what can the IIS migration tool do to help facilitate the process?
Sure. So the IIS migration tool, it'll basically help you transfer Windows users from one server to another. You can copy FTP logins, virtual directories, application pools, SSL certificates, the folder structure, and also assign NTFS permissions, folder permissions. So basically, you can start with IIS 6 and use that tool to help you migrate to 7, 7.5, 8, and probably 8.5.
Okay. Thanks for that, Paul. And to complete our webinar, I want to thank all the panelists for their time today, as well as the attendees for making the webinar available on your schedule. And in front of you, we've got a survey for you to complete. If you could take a second and click on this link. And we appreciate, again, everybody showing up for our topic today. Thank you.